Hello friends, welcome to our channel. Let's continue looking at problem 3607, power grid maintenance. In the previous video, we solved this problem using UniFind plus SortedSet. And in this video, we are going to solve the problem using traversal plus SortedSet. So here, the difference lies in how to find the connected component and name it. So in this video here, we are going to use traversal. So this is the focus here. So the second part is essentially the same. So here, let me first find connected components, right? So for this one, we are going to first build a graph. So in order to build a graph, so I'm going to use collections default dict. So here I'm going to use set to store the neighbors. Then for UV in connections, right? So because it's a bidirectional graph, so we are going to graph U. This is the set. I'm going to add V, means V is a neighbor of U. Similarly, so we add U to the neighbor of V, V to the neighbor of U. Let me restate. So this line means that V is a neighbor of U. This line means U is a neighbor of V. With this done, so actually you can print the graph if you like. So for the first one, so here, so we haven't, let's see, connections, graph UV, yeah, for UV in connections, yep. So we have this, yeah, this one. So means 1 is a neighbor of 2, and 2 is a neighbor of 1, 3, and 3 is a neighbor, 3 connects to 2, 4, and 4 to 3, 5, and 5, 4, right? So if you look at the second one, so essentially isolated because no edge. So now let's do traversal. So here I'm going to write a hyperfunction. So DFS, I'm going to use DFS. So so visited. So let me write it as a none. So this way I can actually use this visited as a representation of the connected components. So here I write with this special format. So because with this visited, I'm going to use it as a set. It's going to be modified during the traversal process. So first, if visited is none, so I'm going to set visited to be an empty set. So then if I not in visited, we are going to do something. If I is in visited, so we're going to stop essentially. So then in this case, visited add, first we add this I, right? And then we look at neighbors. So for neighbor in graph I, right? Then we do DFS from this neighbor, and then visited. Actually, visited is already updated, right? So we keep updating the visit set. So what we are going to do is to return this visited, right? So this is the DFS. So you can call for the first example, right? So for example, DFS, this is the one, right? So here, let's see a result, or CC component, right? So you can print out this one. This should be 1, 2, 3, 4, 5, right? So this is the connected component. But if you look at example 2, it should be just the one itself for this cluster, including starting from 1. So 1 you can interpret as index, or you can interpret as a power station. So now with that done, now let's look at the information parallel in the previous solution. So here are collections. So I'm going to use default dict sorted set again, right? So then in this case, so what we are going to do, so I'm going to use universe, so whole means the set, and then we do traversal. So basically for I in range, so 1 c plus 1, because ending at c starting from 1. So if I not in universe, in other words, if this I is not already in the connected component, we are going to do a DFS. So from this I, DFS. So for this cluster, so we are going to set D of I. So it's going to be a sorted set given by this iterable, right? CC. And then the universe is going to be unioned with this CC. Now we have this set of clusters, so now you can print this D out. So for the first one, you should get 1, 2, 3, 4, 5, just the whole thing, right? Well, for the second one, you will get a 1 and 2, 3, right? So now let's clean this information. So I'm going to make a check table. So in other words, so within each, so the thing we are going to do is to assign a name to each cluster or connected component. So what I'm going to achieve this using the dictionary. So basically for name and nodes in and D items, right? So basically for node in nodes. So all those nodes had a name given by this one. So what we're going to do is check table, the node have this name, right? And because the nodes are different, so we have different keys, but the different keys might correspond to the same name if they are in the same cluster. So that's the philosophy. So once we have this, so we can prepare the return. So again, we get a result. And then for canned, essentially the same as the previous video, IDX in queries. And then we check the cluster name, right? The cluster name is just a check table, right? The IDX. So then if the canned is 2, so if it were 2, basically you want to go offline the IDX. So what we are going to do is the cluster name. So this is the cluster. So if IDX not offline yet, so you're going to make it offline. So correspond to calling the method discard. So this is the one. Another one is if the canned is 1, so we are going to do maintenance check. So in this case, first we check if IDX in the CC name, right? So if it were the case, it means that IDX power station is online. It resolves the check by itself. So we're going to append this IDX. Otherwise, so we need to find the smallest online power station. That is the first element in this sorted list, right? So in other words, the result should append the CC name 0. So this finishes the preparation for the return format. Now we just need to return this result. Let me first do a run. List out of index. Let's see where's the problem. So here is line 3. Let me see where was the problem. Result append the CC name. Let me see here. Discard. Oh, here I think there's one more thing. So we need to check. So here, if not the CC name, in other words, there's no power station online in this corresponding to this cluster already. So we are going to do result append -1 according to the problem requirement. Otherwise, so if there were online power stations, so this is the logic, right? If IDX is online, so we're going to append that. Otherwise, the smallest indexed one. So now let's do a run. Yeah, it passes the 2 test cases. So now let's submit to see the generic case. Yeah, it passes all the cases. So with that done, basically that's the whole point for this video. So here, what I want to comment is that you can make a comparison of the solution here with the solution in the previous video. So the difference lies in how do we get the connected components. So we provide 2 ways, but actually, so the ideas follow these 2 lines to get the connected components. One is unified, one is traversal. So here I'm writing a traversal using this DFS format. So in a recursive format, you can also write it in iterative format, right? So if you want to use DFS, you can initialize a stack, or if you want to use BFS, you can initialize a queue. So actually, the way to write this traversal function to get the connected component. Actually, there are many ways, all different formats, right? Well, the second part is essentially the same. We name the cluster and then we prepare the return. So with that said, that's basically about it for this second solution. So here I want to mention that in these 2 solutions, I introduced or used the SortedSet. So actually, sorted containers can be very useful for some task. So you are very welcome to look at the documentations for SortedSet, look at their methods, right? Sorted dictionary and sorted list, so the same. So with that said, that's it for the current video. Thank you for watching.